All right, so Steve Jobs got canned from Apple, goes and does some other things, founds a company called Next Computers. Apple almost fails as a company. Do you know what Apple did when? What was the kind of the catalyst that led to them almost failing as a company? What big decision did they make the year before that? That kind of led them down a very bad path. It's kind of an interesting. It's kind of an ironic thing. When I say something's proprietary, what do I mean? What does proprietary mean? So this guy right here. What does that mean? Yeah, it's a closed system. Okay, only the ones in the know can fix it, right? So usually it's more expensive, proprietary. Usually you have to go through a very specific place to fix it, that kind of stuff, right? So when I say that something's proprietary, doesn't that usually have a negative connotation? Don't we usually say that's a bad thing for something to be proprietary? So a lot of people don't like Apple because Apple's proprietary, right? It's like, well, it's the Apple way or the highway. Well, I don't want that. I like Android, or I like Windows, or I like Linux because they let me set up my machine the way I want it to be. Any of you feel that way? Well, hopefully a couple of you. Get a spine. Stand up for your rights, right? Hey, why should you have to do what Apple tells you to do? Hey, don't mistake this. I'm not an Apple fanboy. Yeah, I have a Mac sitting up in front of you, but which I have my own hates for. I mean, I am a software writer, and I write stuff for Mac and Windows. Well, I don't want to have to carry around more than one computer, so this is two computers for the price of 1.7. I dual boot this with Windows and the Mac OS. So I can do my iPhone stuff on here, I can do my .NET stuff on here. All on one machine. But my argument used to be that it was two computers for the price of 1.7. Now it's two computers for the price of 2.2. This is the brand new MacBook Pro that has the magic thing on it, whatever. You know how much this machine costs? Also, let me show you the specs. Yeah, this is completely decked out. This is as much stuff as you can put on this machine. All right, so 2.9 gigahertz quad-core i7. 16 gigs of RAM. That's the most RAM you can put on it. Can't put any more. And it's got a 1 terabyte, like, super fast SSD drive. So the hard drive in it is like crazy fast. But everybody else will have them in 4 months or something. And it's got like a extra good graphics card. This is like a $4,800 laptop. Isn't that ridiculous? That's ridiculous. There's no laptop that's worth $4,800. Who does Apple think they are? Get me started. This guy right here. So this the power brick thing, right? My previous MacBook Pro, which I had gotten, it was a 2012. So I used it for a lot of years. I'll use this one for a while too. When you get it, it comes with this brick and this attachment thing here. It came with one that goes in here where you can just plug the brick right into the wall. But it also came with this other extension one to make life easier if you wanted to make it go farther or didn't want to plug it directly into the wall. That's nice, right? $4,800 laptop didn't come with this extension cable. I had to rip it off my old one. Yeah. Now, this guy here has everything's USB-C on it, the future. I'm okay with that. I'm okay with Apple kind of pushing the trend forward. And so these bricks are different than the old ones. The old one, this thing was part of it, so this piece right here was part of this brick. You couldn't take it off. So like yours, right? It's all pieced to that. This one, I can take this cable off. Okay, it's just a USB-C cable. Now, If I go to Apple and I want a second one of these chargers, it's going to cost me $80 for the brick. It's not going to come with the extra extension cable. It's just going to come with a thing where I can plug it right into the wall. But I'm also not going to be able to charge a laptop with it because it doesn't come with this. Are you kidding me? So I gave them $4,800 for a laptop and then $80 for a charger, and I don't get the extension cord or a way to actually connect it to my laptop. That's another $20. This is another $20. It's a $120 charger. Not dumb. Apple's philosophy is this, that usually what ends up happening is this part frays, right? You know, the brick doesn't go bad. It's this piece of it that, you know, frays on the end or something like that. So you just spend $20, you replace that piece. Great. I'm fine. I'm for that. For $80, give me the cable. It pisses me off is what it does. Just dumb. So, I do like Apple because it's allowed me to make a very good living. But I am not a fan of their ethics. But we're talking about proprietary stuff here. I don't have an option. If I want a second charger, nobody else is selling USB chargers, USB-C chargers. Even the wattage of this is a proprietary number. It's an 87 watt USB-C charger. They don't make those. They make 79 watt. Not enough. I cheated the system. You want to know how I cheated the system? Why do you think this brick for the bigger laptop is 87 watts? Why do you think they picked that number? So yours is a 13-inch, right? Okay, so yours has probably a 62 watt charger. Your brick's a little bit smaller. Why do they pick 62 for yours versus 87 for mine? What's that number? Where did that number come from?
We can't use each other's.
No, we could. I could plug yours into mine. Well, not. I could plug yours into my previous 15-inch MacBook Pro, even though it's not quite big enough for it. So I could do it. But what wouldn't I have been able to do with yours? When they pick these, they figure out what's the worst case scenario. What's the most power this machine will pull under heavy load? So for this machine, it's 87 watts. So there could be a situation on your machine where with your charger rather hooked into this, where I'm doing work and I'm losing battery life because your charger is not keeping up with my power drain. Make sense? In theory, this should keep up with all power drain this thing might pull because it's built for worst case scenario. But here's my cheat. Sometimes the battery's close to dead and I'm just charging it overnight. How much power drain do you think my laptop has when the lid's shut? Very little, right? When the lid is shut? Well, you can get a USB-C cable you can get a USB to a USB-C cable. And so I did that for $11. I plug this thing in like it's an iPhone. So I go from a USB charger to USB-C. It doesn't charge it very fast. It charges about 10% per hour. So you can, if you get it down to 40% or something, you can charge it overnight for $11. Stick it to the man. That's right. And technically, I haven't tested this yet. There's 4 USB-C ports on this, and you're supposed to be able to charge out of all 4 of them. So for $44, plus the cost of a USB hub, I should be able to have a little wire party going on here and just have 4 plugs going into all trickle charging this thing. All right, but this gives you a little bit of my recent hatred for Apple. But the idea of this proprietary nature, usually we would think proprietary is bad. Proprietary has been very, very, very good to Apple. In fact, Apple almost failed as a company when they chose to stop being proprietary. So in the late 90s, even actually mid-90s, Yeah, mid-90s. It was mid-90s. 93, 94, somewhere in that ballpark. Apple started allowing other companies to make Macintosh clones. So no longer did you have to go and buy a computer from Apple in order to run Apple software. You could buy a clone, a Macintosh compatible computer. Usually they were much less expensive, which took money out of Apple's pocket. And Apple almost failed as a company. So, did Apple rehire Steve Jobs? I mean, Steve Jobs ended up back at Apple, right? Did they rehire him? Did they come back groveling and apologize? Say, oh, well, we're sorry we fired you and we're out of money. We need you to pay our bills. Come back, please. Is that what happened? What happened? Anybody know? I still have my next computer up here. Huh? What do big companies usually do? One of their hobbies is to acquire smaller companies, right? So Apple acquired Next Computers. And with that purchase came Steve Jobs, who Apple decided to install as their CEO, the interim CEO. But then they started calling him the iCEO. Why the iCEO? iPod, iMac, iPhone, iBook. They had a laptop called the iBook. Basically, Apple puts I in front of anything, it makes zillions of dollars, right? So he was the iCEO, who then later became the reestablished full CEO. But you told me that you had never heard of Next Computers, right? I mean, you looked me in the eye and you lied to me.
So this is Next Computer?
You're using a Next Computer with an Apple logo on it. So if I go and look up, so we're going to be working with strings in here in Java. If I go and look up NS, well, here, let me look up Objective-C string. It's going to take me to, something here called an NS string. Here's a NS string from Apple's, this is Apple's documentation. So this is an Apple branded site, right? Next step string. It's in their language. When you write stuff for iPhone, you're using NS strings. You're using NS everything. iPhone's running Next operating system. It's running Next operating system with the fancy Macintosh front end. You know, what do they call this? They call this guy Aqua, with the the things launch out. They look all nice and animated and everybody claps. We're all happy. They just threw that on top of Unix. So Apple went out and they stole OpenBSD Unix. I mean, it's no more stealing than other companies do. They took an operating system that was already good. I think somebody back there was saying something about multitasking, right? Which is what was the big difference? We ended the first part of class with kind of asking the question of what happened between OS 9 and OS 10. Well, OS 9 had multitasking, but they had something called preemptive multitasking. Okay, preemptive multitasking is like fake multitasking. It's like, oh, okay, well, you want to run this program and you want to run this other program? Fine. Whichever program you have in the foreground, I'm going to give that guy 99% of the CPU time. But this other guy, I'm going to give him just enough love to keep him alive. This was during the time when the internet started coming into a thing. So now, if you're going to download a big file, let's say you're going to download a 1 gigabyte file, something like that. Back then, 1 gigabyte was astronomically large. So back then, it might have been you're going to download a 4 megabyte file, and you plug that, or you start the download. do you just sit there and stare at it and twiddle your fingers? You're probably going to do something else on your computer at the same time. So you open up your web browser. Back then it would have been like Netscape or Mosaic, the Mosaic web browser. Firefox came out of the Netscape project. So before that we had Netscape, which was a little pulsing N. Oh, those were the days. So you put your download in the background. And when you come back and check on it in 2 hours, you realize it's made next to no progress because it was getting almost no CPU time. So that's not really multitasking. That's technically allowing more than one application to stay alive on the machine at the same time. So basically, Apple's operating system sucked. Right? The people who liked Macintosh computers then, they were the Macintosh fanboys. Okay? They were the people who were already heavily drinking the Kool-Aid. Windows was so much better by every single measure. But you couldn't talk a Mac person into thinking that, right? No, Mac people, they would get upset. They would go and protest. They would say, "Oh, you know what? If only the software came out for Mac as well as PC at the same time, everything would be great. Why are they doing this to us?" Well, if you're somebody who writes software, do you write it for the 99% of the people who are running Windows, or do you write it for the 1% of the people who are running the Mac operating system that crashes every 5 minutes? So I had back before Macintosh moved over to Intel processors, I had an Apple machine as well as a Linux machine, and a Windows, Linux, and one of my hobbies was getting all these guys talking to each other. All right, and I can't tell you how many times I would turn my monitor on because I leave the computers on, and it'd be 10 in the morning and the clock would say like 2 a.m. That was the time it died. So mouse would still move too. It's like false hope. Still move the mouse around. Couldn't click on anything though, and you just had the little clock up there just said 2:06 a.m. That's when things went south. It's because it was a crappy operating system. It wasn't very good. So Apple abandoned it and moved over to OS 10 or OS X. Does the X stand for the X in Unix? Does the X stand for the X in Next? Does the X stand for 10, Roman numeral 10, for the number that comes after 9? Who knows? Pretty clearly, it's the next operating system with a fancy Apple front end on it to make things look nice. Make sense? Well, so proprietariness works for Apple. It does. I mean, one of the reasons that you've heard people say before that Apple stuff just works, right? Does that mean it's better? When people say that the iPhone just works or that your Mac computer just works, does that mean that they're actually better products? When does the iPhone work the best? When you're using it inside of an Apple ecosystem. So if you're using an iPhone with a Mac, or with an Apple TV at home, with all those other things, it all works seamlessly together. Apple software runs pretty well on their own hardware. Now, how many of you run Windows in here? Most of you, right? Okay. Does Windows suck? Oh, Windows is pretty good. In fact, I would argue that Windows is shockingly good, considering how hard the problem they're solving is compared to the problem that Apple solves. If I'm Apple, at any one point in time, I have like 6 different computers that I'm selling? A couple different processor configurations, but really like 6 machines. And those machines only run my software. I only have to worry about my software working on 6 machines that I built. A much easier problem to solve than the people over there at Microsoft who are, so they write Windows. So we got Windows 10 out now, right? And how many different computers does Microsoft build? Microsoft doesn't build computers. Dell builds computers. HP builds computers. Asus builds computers. A zillion companies build computers that all expect Microsoft software to work on them. Isn't it pretty amazing how good Microsoft Windows is considering they don't control any of the hardware? I mean, could we say that the Mac OS is a little bit more stable? Maybe. I don't even know if that's a fair statement to make, but maybe you could make that argument. Let's say it's like the Sprint commercials, right? Let's say it's 1% more stable. It should be. They control both sides of the coin. How many of you are Android users versus iPhone users? Who uses Android in here? Better be at least half of you. Who uses iPhone in here? So the rest of you just don't. Oh, really? A lot of iPhone users. Usually it's just bad participation. Okay, so who's the iPhone users in here? Wow, impressed. Okay, now who's the Android users? Who was the Android users again? Okay, why Android? Oh, she's a proud Android user right there. Right here. Why Android?
Okay, one reason is because like no phone lasts with me more than for 4 months, so that's why I better keep my preference to Android. It's like Apple, I find it so sensitive.
Okay.
Screen.
So like they break easily.
Yeah, the big reason.
Okay.
That's one of the reasons.
So you need like a rugged phone.
Yeah.
You don't want something that's like built to be like knife thin.
Right now, my phone is this way. Like you can see how I use my phone. This is my fourth phone in USA.
So what do you do? Why do you break? How do you break it?
I have no idea.
Is this like an anger management issue? Because I'm like a big guy. I keep my phone in my pocket, and I've never broken a screen or anything.
You said you only talk to your mother and your.
Well, I have my phone out all the time though.
Yeah.
I mean, I'm using it all the time. I just don't talk on it. I mean, I text and email and all that stuff all the time.
When assignments are tough, she broke her phone.
I mean, it sounds to me it's like an anger management issue. You know, somebody crosses her on the phone, it's whoosh, spike, right? Isn't Google solving a pretty similar problem to Microsoft in terms of they write an operating system to run on a whole bunch of different cell phones? Where Apple is solving the old Apple problem? It's like, oh yeah, iOS 10 runs great as long as you have an iPhone. But we don't want you to have too old of an iPhone. So we're going to make sure it only works reasonably well in the most recent couple. So if you're more than a couple of years out of date with your iPhone, we're going to have you come back in and give us some more money. That's what we need. So those iPhone users in here, how many of you are running? So let's go. Let's find out how old your iPhones are. How many of you have an iPhone 4S or newer? Or newer. A 4S or a newer phone. So that means you have a 4S, a 5, a 5S, a 6, a 6S, or a 7. Okay. Anybody have anything older than a 4S?
I used iPhone 3GS for 10 days.
For 10 days before you shattered it. Yeah. Yeah, I'm going to steer clear of you, I think.
The screen broke. It's just fell.
All right, so how many of you have at least an iPhone 5? 5S? 6? 6S? 7? Who has an iPhone 7? 2 people? Why'd you get an iPhone 7? What'd you have before the 7? 6 or 6S? 6. Okay, so you waited 2 years. What did you have before the 7? 5. Oh my gosh. So you were one of those guys that Apple forced into getting a new phone. You had your 5, they came out with a new operating system, like, this doesn't work.
I bought a new one because I broke my screen. It's totally damaged.
But even if you hadn't broken your screen, you wouldn't have been able to install iOS 10.
I used iOS 10 for from the day one I'm using.
And was it usable?
Yeah.
On a 5?
Yeah.
Oh, wow. Apple was nice to you.
For some reason, right around the time when the iOS 10 came out, my iPhone 6 just stopped charging.
Part of their evil plan. They send the little command to all the phones and say, okay, well, your battery life just got a little bit worse. Please visit your local Apple store. Yeah, so I use this is a 7 Plus. I had a 6S Plus before this, then a 6 Plus. But I write software for them, so I get one every time. Half the time, Apple sends me free ones, though, so I like that, too. And then I can sell my other ones, so I make money off of them. Sticking it to the man. Have to use it to fund my chargers. my laptop chargers. All right, so Apple's proprietary. Most of us look at that as being a bad thing. The reality is it was one of the best things for Apple, and they almost failed because they tried to be less proprietary. Steve Jobs came back in, saved the day. He bankrolled the company until they got their feet back underneath them, brought next computers with them, came out with the iPod, iPhone, blah, 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 blah. Apple now is one of the most valuable companies on the planet. Okay. We were talking about POSIX, operating systems. Operating systems that use a file descriptor as the everything's a file. We were looking at our Hello World program in a low-level language, right? And I asked the question, why does the operating system matter? It's because the operating system has some special system calls in it which know how to do something very specific using that particular CPU on that particular operating system so that we don't have to write even more lines of code. So the fact that we passed a 4 in here, and then we interrupted the CPU and said, Linux, I need you to come take a look. Okay, I've thrown some things in 4 buckets over here. I think we're ready for you. So we interrupt the CPU, we call out to Linux, Linux wanders over, the very first thing they do is they look inside of this bucket right there. And they find a 4 in there. And Linux goes, 4, my old friend. That's our syswrite system call. And you know what, if you want me to write something, I'm going to need 3 pieces of information from you. I need to know what you want me to write. I need to know how long it is. And I need to know where you want me to write it. The file descriptor to where you want me to write it. Well, it just so happens, before I called you over here, Linux, I went ahead and I stored those 3 things that you needed for you. I put in EDX, which you would have to have known that's where it's going to look for that. So these were very specific buckets. We had to put those 3 pieces of information. This was a very specific bucket where we put that 4, what system call we're calling. So we said, we want you to write it. Well, we want you to write this message. This is how long it is. So this is really the base address of that message. This says, how far do I need to go from that base address till I get to the end of the message? And then where do you want to write it? Well, I want to write it to 1. Well, what does 1 mean? Well, 1 maps to a very specific file descriptor on Linux. Specifically, it maps to a file descriptor called standard output. And when you think about a computer, where's the standard place that we usually see our output? The screen, the monitor. So standard output says, go to the screen. Linux came over, says, you want to do syswrite? Cool. Where do you want me to write it? Standard output. What do you want me to write? Oh, here's the base address, so I'll start writing from there. And how long should I keep writing? Length, number of times. Done. Magic. Power tool. So behind the scenes, Linux went and did all your dirty work for you just because you staged 4 values. This was the easy version of this program. Otherwise, you would have had to teach that computer, assuming there was no operating system, how to get individual characters, H, E, L, L, O, onto a monitor. So you're going to have to talk to that monitor directly. You had to write the I/O to talk to the monitor. How many lines of code do you think that would have been? Let's round down and say a lot. The operating system saved the day here. It did all this hard work. the magical syswrite, whatever that does. Wrote stuff out. So finally, so now hello world's been printed to the screen. Then we come back to our program here. And now I overwrite what used to be an EAX, the 4, with a 1. Now EAX, now that we've learned, is the place that the Linux operating system goes and looks to find out what you want to do. So we overwrite the 4 with a 1. Now we didn't overwrite any of the other values, but that's okay. Because when we interrupt the CPU this time and call Linux back over, Linux goes and looks in the EAX bucket again and says, oh, what do you want me to do this time? Oh, you want me to do number 1. Number 1 is sysexit. It just so happens I don't need anything else from you. You want me to kill off this program? Consider it done. Program terminates. That's the end of the hello world program. That make sense? So do we pretty much understand what went on there? And we could appreciate that a human being could write this code. A human being did write this code. Okay? We even used a power tool. It might be intimidating. We might be a little bit scared about how bad is that guy? What if we had to write him? Who wrote syswrite? Well, that's an operating system programmer. He's smart and hardworking and probably a nerd, right? We don't want to be him. We want to. But you know what? This is too difficult for us. Look, we're humans. We're lazy. We got better things to do. We got cricket matches to watch. We can't be sitting here looking up manuals and finding out what system call numbers map to what. That's beneath us, right? And you can see it in his eyes. I'm not doing that. Mm-mm. I mean, we're talking 3 wickets. Yep. It's 3, right? 3 wickets. Nailed it. All right, so you guys go back and email Dr. Locklear. Teacher's a lunatic. I mean, I kind of liked it, but I mean, nobody should get that excited about computer science. All right, so where are we at here? Oh, 3 different kinds of programming languages. So then we have our high-level language. One-to-many relationship with the CPU. Oh, yeah. Every line of code we write in a high-level language translates into a whole bunch of assembly language code. So what does hello world look like in Java? Done. One line, Java, you do the rest of the work. I'm going to watch cricket on ESPN 8, the Ocho. Anybody get that joke? Movie Dodgeball. Nobody saw Dodgeball in here? Don't know who the Teenage Mutant Ninja Turtles are. You don't know who Dodgeball. The movie, you know ESPN, right? The channel in the movie Dodgeball, which is a comedy. There's a channel they reference often. They're called ESPN 8, the Ocho, because you know how there's like an ESPN 2. That's like a second. Well, ESPN 8, the tagline is, if it's almost a sport, it's on ESPN 8, the Ocho. So that would be like cricket, something that's almost a sport. All right. So 3 kinds of programming languages. Now, when we talk about high-level languages here, tell me about some of the languages you've heard of. Things that you know or think are programming languages. Just start throwing a couple out here. I'll get us started. I have mentioned Java. All right, so we got one. C, C++, Python, okay. Who? The last one sounded made up. Pascal, okay, it's not made up. Very old language though. Who? JavaScript? Okay. So what's the difference between Java and JavaScript?
I think one talks to the servers.
Let's not even go down that path yet, but we're going to answer the question and say absolutely nothing. Well, actually, everything. Everything's different. They have nothing to do with each other. Java and JavaScript completely unrelated. Just happen to share that first word. But they are both based on the C programming language, which we'll talk about here in a second. Any other languages we want to throw up here? Swift. Oh, spoken like a true next computer guy. It's the Swift programming language. Love Swift, right? Yeah. We'll bash on Swift in a little bit.
Actually, I bought this to learn Swift.
You brought it to learn Swift?
Because I can't do it on Windows.
Well, you could if you did a Hackintosh, which doesn't work very well. So you think Swift is the best language? That's the one to go with?
I know Vue.net, but I don't know Swift, so I just wanted to see how Swift works.
Oh, so you know VB.net. Now, so what I asked, does anybody know any programming in here? You just didn't participate. Is that what you're saying? But we don't have to worry about that because he doesn't even know he's running a next computer. And he didn't know who the turtles were. So really, you need review, at the very least. All right, so we'll bash on Swift here in a little bit because about 95% of the programming I do right now for my current clients is all Swift. Just a garbage language. Just garbage. Yep. I'll tell you why. All right, so we got Swift. Anything else you want to throw on this list?
Is there a difference between C, C++, and C#?
Oh, yes, there is. Oh, we don't even have C# on the list. But I'm so glad that you asked. That is the perfect question to ask. And about how I'm going to spend our next hour is what's going to happen. And when we leave tonight, you're going to have the whole perspective of programming languages all like in one. This is just, I mean, you're going to watch this over and over again. This will put you to sleep every single night. And I could see him already doing head bobs back there. You know, he's like smiling. He's like, you know, he left and did like a big caffeine burst type thing. Ay. Okay, so let's do a couple other slides here. Well, first of all, how many of these languages do you see here do you think are high-level languages versus low-level languages? All of them. Every single one of them. So basically, every language that any of us have heard of is likely a high-level language because that's what humans like. Now, I've mentioned assembly language to you now, right? And we've seen it, and we don't like it. We don't like it, right? Anybody in here like this? I kind of do, but I'm kind of old school. I grew up on that stuff. All right, but yeah, this is what we program in these days. So now she asked the perfect question. What's the difference between all these things? Okay, she specifically asked the difference between these guys, and oh, that is a good story. That is a good story. But let's get a couple other slides in here first. So now I already have one slide here that says there's 3 kinds of programming languages, right? Okay, so now I'm going to have another slide that's going to look almost just like that one. We have 2 kinds of programming languages. So we have, and each of these slides that say some number of kinds of programming languages looks at programming languages through a different lens. All right, so 2 kinds of programming languages. We have loosely typed, we have strongly typed languages. Okay? Loosely typed and strongly typed languages. Now, loosely typed languages, this all relates to variables. So variables, this is how we remember stuff. All right, because I go back, I'm going to add something back here near the beginning. If the job of our programming language, whatever language we use, if its job is to let us tell a computer what to do without changing how we solve problems too much, shouldn't we kind of be able to articulate how we solve problems? What tools do human beings use to solve problems? Well, we use our memory, right? If we didn't remember stuff, we'd have a lot of trouble. Okay, we use our memory. We ask a lot of questions. And we do repetition. All right. Now, I'm going to copy this slide. I'm going to paste it. And I like calling this slide the mapping. 100% of all programming languages, every single programming language that exists has facilities for these three things. Typically, memory is emulated through something called a variable. Asking questions is emulated through something called a conditional. Usually these are if statements. And we'll talk about why it's usually an if statement. And repetition happens through loops and methods slash procedures slash subroutines if you want to go real old school. 100% of programming languages have facilities for those three things. The language doesn't matter. Programming is a skill set. I don't care what language you pick up. If you can figure out how do I define a variable, how do I ask a question, and how do I repeat stuff, you can solve a pretty large classification of problems in that language, even if you just learned it 5 minutes ago, if you already know how to program. That make sense? All right, so that's the mapping. Every single language is going to give us facilities for those things, and we'll talk about that. So when I say there's two kinds of programming languages, loosely typed and strongly typed, what we're really talking about is how it relates to that memory piece, the variable piece. How do we remember stuff in the language? Loosely typed languages do not require us to describe the kind of value we intend to store in a variable. Strongly typed languages, I'm going to just copy that, paste it. They do require us to define what kind of value we're going to store in a variable. So to give us a real life example, in a strongly typed language, in a strongly typed world, I'll pretty often will bring things back to real life because programming is an emulation of real life. It's allowing us to solve problems the way we typically solve them in real life. The second we get too intimidated and get too sucked into the techno-babble world is the second that we stop learning how to program because we've forgotten all the great problem solving that we learned as a human. So I go out to Target and I buy one of those Tupperware containers, okay? And I'm going to put tax receipts in this Tupperware container. I'm going to get out a Sharpie and write on the side of it, tax receipts. All right, put it under the bed. Every time I have a receipt, I throw it into the container. That container is earmarked for tax receipts, okay? Because I wrote it on the side of it. Strongly typed. Now I've decided that I don't need to keep tax receipts anymore. We're under a new administration now. Everything's lost. So I'm just going to go ahead and we're just going to stop keeping receipts. But instead, I want to store shoes. So could I just put shoes in that Tupperware container? Will shoes fit in there? Can I pull that container out from under my bed, take the lid off, dump the receipts out, and put a couple pairs of shoes in there? In real life, we could. Couldn't we? Chances are a couple pairs of shoes would fit in that container. But, unfortunately, I already wrote receipts on the side of it in a Sharpie. Can't put shoes in there. Not in a strongly typed world. I got to go back to Target and get a new container specifically for holding shoes. Even if I'm not going to keep receipts anymore, it's going to have to go unused. Waste of money. Make sense? That's the strongly typed world. Now, a loosely typed world would say, oh, I used to keep receipts in it. Fine. Let's dump them out. Now let's put some shoes in there. Everybody's happy. Which is better? It's a trick question, by the way. Oh, so because I say it's a trick question, the answer is the first one's better? Okay, I'm going to here's the caveat. We're not going to label them. So now you have two containers under the bed. All right? In a loosely typed world, we have two containers under the bed. One of them has your shoes in it. And both these containers are opaque. They're not clear. So they're like a dark container. You can't see what's in there without taking the lid off. One of the containers has your shoes. The other container is filled with rattlesnakes. Go put your shoes on. We're going to the movies. Do you wish those containers were labeled? Now, let's go back to the less dangerous. One container has tax receipts in it. The other one has your shoes in it. All right? Nobody's going to the emergency room tonight. All right? So now, we go get your shoes. You're going to go up and play in a guessing game, right? Just peek at each one. You find out the one. You go and do it. We'll take the exact same situation, except now we've put a label on the boxes. Now we're in a strongly typed world, and I say, go get your shoes. What's the advantage of having the labels? Speed. Faster. Strongly typed are fast. Okay? And one thing to throw in here is they're relatively fast. Computers are pretty fast. So from a human being's measurement of things, for most applications, we aren't going to feel the difference between a strongly typed and a loosely typed language. Okay, for most things. But, for example, nobody would write a video game in a loosely typed language. You know, things like high performance, lots of explosion video games, those are all written in strongly typed languages because the focus needs to be on speed, even though it's a little bit less convenient because we had to label the buckets, right? See the trade-off here? So what did we gain from loosely typed? Well, we were able to be a little lazier, right? Didn't have to label the buckets, and only when we needed to retrieve something did we have to play the guessing game, or in this world, we might have to check both and grab the one that we wanted. But, so these guys would be relatively slow. But very, very important here is not to say that, oh, well, then strongly typed is better than loosely typed. It ultimately comes down to what's the right tool for the job. And more times than not, a loosely typed language is less complex to learn than a strongly typed language. Okay? They're generally less general purpose. So with that in mind, let me throw another slide up here. There are two kinds of programming languages. We have domain specific, and we have general purpose. So a general purpose programming language is built to solve a giant classification of problems. Basically, it's a language designed to solve any kind of problem that a human being can conceive upon that a computer should be able to solve. All right? Now, these are giant languages. Okay? Languages like Swift, like C, like C++. Okay? Languages that have a lot of stuff built into them because you might want to do a bunch of stuff. And I'm sure I'll mention this again later, but for instance, I've been writing Java since the day it came out. Okay, Java came out somewhere in like 1994 or something like that. So the first day that people could use it, I started writing Java stuff. I was interested in it. All right. So certainly I must know the entire Java language, right? I bet you that I have seen less than 10% of the Java programming language. I've seen the stuff that I've needed to use to write the code I've written. Now, that isn't to say that I don't possess the skills to see in the documentation something that I haven't previously used and be able to instantaneously use it. That's the skill of programming, not memorizing a language. Okay, you're always going to have a reference book sitting in front of you. And what's going to end up happening is you're going to find that 95% of the time, you use the same stuff. So after some repetition, you're going to end up memorizing it. And every now and then, you have to go a little bit outside of your comfort zone, and you have to go and look at some documentation. But being able to read that documentation is pretty important. All right? But general purpose languages are large. Domain-specific languages are relatively small because they're solving very specific problems. All right, and we'll talk about some examples of these, but just as a general rule here, some languages are built to solve very specific. For instance, there's a programming language for dishwashers. That when a repair person comes out to your place to fix the dishwasher, they have some codes they can put in, and you imagine a dishwasher only does kind of like 4 or 5 things, right? So that's a pretty tiny language. There's like 5 or 6 commands that he has to know. That's it. That's an easier language to learn than that Java language that I've been messing with for 25 years, or how long was Java? So how many years ago was 94? 20. Whew. Is anybody in here not 22 years old? You're younger? You're 20? Hey. That's why you understand cricket. It's a young man's sport. That's what it is. You're 24? Well, I told you my 21st birthday is Friday. And I've been programming in Java for 22 years.
Like you mean the 21st anniversary to your 21st birthday?
Right. And I've been married for, I guess I've known my wife for 20 years. We started dating very young. What's up? Oh, I remember when I was 21, I was young and fresh. All the joints worked. I was telling you during a break, and I won't get too far off topic here because we'll take a break here in a few minutes, but I was down in Florida for basically 2 months, and I tried to play golf every single day. I did,
You had fun time.
but I shouldn't have. There were days where like my back was killing me. I could barely walk. It's like, well, everybody back home is complaining about the snow, so I have to go out and play golf. And I'm like, it's pretty bad. All right, so different kinds of languages. One's not necessarily better or worse than the other. It's what's the right tool for the job. Okay, so that's kind of the reason I wanted to point that out is don't look at loosely typed languages as being bad. Good proof of this, if we go back to our list here, how many of these languages here do you think are loosely typed languages? Do you think more than 0? Yeah. We didn't have any low level languages in here. These were all high level. But do you think we probably have some loosely typed languages in there?
I guess C is
Nope.
Pascal.
Pascal, nope. Strongly typed. Loosely typed right there, Python. Very popular language. Yeah, I mean, Python is extremely popular today, especially for like data science things, but also some web stuff. JavaScript is loosely typed. Swift tries to pretend like it's loosely typed, but it's strongly typed. We'll rip on Swift some more later. You maybe heard of like PHP.
Yeah.
PHP is loosely typed. Ruby, also loosely typed. So many of our web languages are loosely typed languages. Many of our native languages for writing desktop and mobile applications are strongly typed. One's not better or worse than the other. Right? When speed is of the utmost importance, like in video games, you never want a loosely typed language. Because there's overhead. You got to check both buckets. Which one has the rattlesnakes, right? We don't want to do, we stopped checking. We got rid of the rattlesnakes before we checked. But, you know, loosely typed languages will be slower than strongly typed languages.
Question. So what if you still define your variables in just loosely typed languages?
Loosely typed languages would not allow you to define your variables. Yeah. They won't let you say, this is a variable capable of holding a number.
Okay, I kind of got that confused because you said it does not require it.
Yeah, no, that's a good point. That's a good point. See, I like her. She challenges me. I like that. That is a very good point. Does not let us describe the kind of value we intend to store in a variable. Yeah, it's not part of the syntax. No, very good point. Yeah, it's usually those languages will be like var a is equal to 7. And then I could say a is equal to hello, one line later. So I could put a string in it right after I put a number in it. I defined it by saying var, but not what kind of var. Or in a strongly typed language, I would say like int a equals 5. So I've defined it as an integer. But then I can't say a equals hello because it's going to scream at me and say that box was built for a number. Now you tried to put a string in there. All right? So, but this ultimately comes down to this idea that our computers are fast. So for most applications, loosely typed languages are completely acceptable, will be unnoticeable to us as humans in terms of their slowness. But certain applications really need to be fast. Every little nanosecond makes a difference. Those are the languages, those are the projects you want to write in a strongly typed language. Because even little slowdowns do add up, right? Even if this thing takes 1 microsecond longer than this thing, if you do it enough times, a human being is going to notice 1 billion microseconds, right? We're going to feel that. That's real time to us. But we're not going to feel 3 microseconds or 17 microseconds. So you do something a little bit faster enough times, then all of a sudden it starts making a difference. All right, 2 kinds of programming languages, loosely typed, strongly typed. 2 kinds of programming languages, domain-specific, general purpose. There are 3 kinds of programming languages. We have functional, procedural, and object-oriented. Now, functional languages I'm not really going to talk much about because it's they're very different languages. If you've ever used like a Texas Instruments graphing calculator or something like that, a language that's built in terms of functions would be like take the sine of the cosine of the tangent of 7. So we're passing the result of this function into this function, into this function, and ultimately it boils down to a value. Most functional languages tend to be loosely typed. They tend to be, they could be general purpose, I guess. That's a fair thing. But they're just very different. So it's not in our best interest to look at them too closely in here because it kind of breaks down our connection. Having said that, in computer science, so how many of you have heard of a language called Lisp or Scheme? Okay, so these are languages that in the computer science world are pretty popular languages. One of our students just got a job as a scheme programmer, and I teach one of our upper division computer science classes. My PhD's in computer science, not IT. So I only teach our programming classes in the IT major. So so I teach our upper division computer science class that's programming language theory, where we write our own programming language in there. And we use Scheme to write a programming language. Scheme is a very small language. You can learn it very quickly. But we use that because it forces us, since it doesn't have a lot of stuff built in, it forces you to have to build all the constructs that allow a full language to work. So it's pretty interesting. And the students hate it because it's hard. But then several times in the last 17 years, students have come back and say, you know what, had I not had that Scheme, I wouldn't have learned this, that, and the next thing. And they keep getting jobs doing Scheme. So functional languages do have a place in the world. But it's not that common thing. So we really, for us in here, care about those two. All right. So procedural languages tend to be monolithic in nature. And what I'm about to write here is going to be nonsensical. And then I'm going to give you a legitimate example that's going to work fine. All right? Does that make sense? And are executed linearly, whatever that means. Object-oriented languages wrap data within objects, which mimics the ways humans solve problems. All right, so the best way to talk about the difference between procedural and object-oriented languages is by thinking about the procedural telephone versus the object-oriented telephone. All right, so we're going to go back old school. So I'm going to tell you that over here on the desk, I have a telephone. You have to use your imagination a little bit. The whole Teenage Mutant Ninja Turtle thing all over again. All right. So over here, we're going to talk about the procedural telephone first. You walk in the room and you see a pile of wires on that table. Whole pile of wires. And I say, you know what? That's a telephone. You walk over, you kind of expect it. You just find a bunch of wires, and finally you find a handset. You listen to it. You hear a little dial tone, as if those still exist. But you know, how many of you have never heard a dial tone? Everybody's heard a dial tone. At some point, I'm going to have a class where nobody's heard a dial tone, and that's going to be okay. So you find something. You hear a dial tone. You find some buttons sitting there. Finally, you're convinced it's a telephone. It doesn't look like a telephone to you. But the function of it, you're finally convinced it's a telephone. Okay? The object-oriented telephone will look like a telephone. You'll look at it and say, yeah, of course, that's a telephone. Now, if you walked in, let's say you walked in here and I had 10 different telephones set up on the desk here. Do you feel confident that you would be able to, if I gave you the phone number, that you would be able to make a phone call on all 10 of those phones? We roughly have an idea of how to use a telephone, right? So even though not every phone looks identical, you expect to find the buttons to dial the number on all the phones. You expect to find the thing you talk into on all the phones. You'd probably figure it out, right? A telephone pretty much looks like a telephone. When you go to the telephone aisle in Target, you know, there's a whole bunch of phones on the, you know, on that aisle, and you know they're all phones. Now you're just looking for the one that has the thing you're interested in, right? You know, whether it has the built-in answering machine and all that crap. You know, we're going a little bit dated here, but you know, punchline is the object-oriented telephone looks like a telephone. We know that all those wires are stuffed inside of it. We know they're there. But most of those wires we don't have to work with, right? When we use a telephone, we just need the handset and the buttons. And then we can make phone calls, right? So an object-oriented device only exposes the public interfaces and hides the details within the object. So if we really, really, really needed to get at those wires, we could. I'd probably just have her come over and spike the phone, right? So now she's paying attention. I get it. So have her grab the phone, spike it. Now we see the wires, right? And they're all over the floor. She's screaming again. I mean, we're all running. We're scared.
It's not accidental. I don't do
Okay. All right. So we believe the wires are inside the phone, right? But we don't see them. We maybe never will see them because we don't. Once the phone was built, we don't have to worry about those wires. We only work with the phone. We only work with the public interfaces, right? Now, the procedural phone, all the same stuff is there, but we're missing a little box that we shoved all those wires into and then closed the box up and then poked holes for the public things. So the only difference between a procedural language and an object-oriented language is Tupperware. It's a level of organization. That's it. So often, programmers try to separate these two things by this giant chasm and say, well, I really am more into procedural languages than object-oriented languages. I just like the old school feeling of it. It's just a box. You took your crap, you threw it in the box, you put the lid on it. That's an object. And you poked a couple holes so that it was easy to get to the few wires you needed, right? You've ever hooked up a TV or something or a video game system where you have all those wires, right? What do? You stuff all the wires, never have to touch again inside of something, and then just have the 2 or 3 little HDMI cables poking out. Those are what I need, right? That's it. That's object-oriented programming. If you don't wrap the wires up, it's procedural programming. Make sense? Why is object-oriented programming better? It's newer. It's the modern way we approach programs. Why do you think that's the modern way? What's better about it? Why is it easier to use? Why are object-oriented languages easier to use? If you walked into Target today and they had 2 telephones, both are on sale, $10. One of them looks like a telephone, the other one looks like a pile of wires. Which one are you going to buy? The one that looks like a telephone. Why? Is it really that?
It minimizes the space, it minimizes the space. It's like...
I used the example a few minutes ago that if I lined 10 phones up here that actually look like phones, all of us would be able to dial a number on them, right? Okay. Well, now I'm going to throw a pile of wires up here. And I'm going to promise you it's a phone. Good luck. Okay. And I'm going to say, come and dial a number. That's not how people solve problems, right? As things get complex enough, we need there to be some order to our world, right? When we solve problems in real life, we solve problems in terms of objects. When we go to the grocery store, we don't carry all of our individual objects out individually. If we only have 2 things, maybe we do. But if you have 20 or 30 things you bought, you throw them in bags, right? We'll open the bags when we get home as we throw them into the refrigerator. Right? We package things up as people. That's what we do. So object-oriented languages are our modern languages because that's closer to how human beings actually solve problems. So let me just start a slide here. Oh, so excited about this next part. Evolution of languages. All right, so let's take 10 minutes, a real 10 minutes this time. So 9:05. Back at 9:05.